bet I could, like, set this one up. I know. Here's a classic technique.
Whoa!
Oh, yeah. That was effective.
Nina Lanza works on Mars, by which I mean she works here in New Mexico, but she works on Mars by way of NASA's rovers, Curiosity, and Perseverance.
So this is the surface of that rock. That's rock varnish. And this is a material that we believe is made by microbes. And this type of rock is also seen on Mars.
An expert in geology and many other things, Nina is trying to help us understand how studying the Earth's past can help us prepare for the future.
Would you like to break a rock?
Sure. All right.
Oh, look!
Oh, yeah. This is a piece of it.
Beautiful. Look
sure.
at that.
Yeah.
And look, varnish. You
Yeah,
got it.
yeah. And my daughter used to bring rocks home.
Well, this is a great rock to bring your daughter because it has this incredible story. You know, it's the story of New Mexico, but also broadly, the story of how life finds a way to exist in even the most inhospitable environment.
Yeah. In this episode, we'll look at what science tells us about where we've been, where we are, and where we're going. We'll talk to a planetary scientist, a theoretical physicist, and a futurist about how harnessing our curiosity just might help us persevere as a species. And we'll continue our eternal search for meaning and purpose in our vast, miraculously complicated, rapidly expanding, and incomparably mysterious cosmos. This is Dispatches from the Well. You meet someone on a plane. You're having a casual conversation.
That happens, yeah.
People ask, what do you do? How do you explain what you do to strangers?
That depends a lot. You know, there's a joke among people like myself who do a little bit of astronomy, a little bit of physics. If you want to talk to the person, you say you're an astronomer. If you don't, you say you're a physicist. And they generally say like, oh yeah, I was bad at physics in high school. That's the most common response that you get. But occasionally they're fascinated because it is fascinating stuff.
Sean Carroll is a theoretical physicist working on foundational questions in quantum mechanics, space-time, complexity, and cosmology.
If there's not a reason for our existence given to us from the outside, is it possible for us to create that purpose?
He's the author of numerous books, host of the popular Mindscape podcast, and has even worked as a science consultant on Marvel movies like Avengers Endgame. He's someone who manages to mix a no-nonsense approach to existing scientific knowledge with a genuine enthusiasm for revolutionary new ideas that could change the way we think about reality. I'm curious, when you think about the fact that this ought to inspire awe and wonder in people, as much as it does a sense that, wow, we really can say rather definite things about the world around us, and there's something remarkable about even that.
As much as the spirit of science is we should explore and always be willing to change our minds, it is also true that we've learned some things. We might improve our knowledge, we might add to it, but we're not going to suddenly realize that Ptolemy was right after all and the Earth is the center of the solar system, right? Like that's in the books. We're done with that. We've learned that. That's not to say that we know all of physics. We don't know what dark matter is. You know, we don't know what quantum gravity is. Many things we don't know. But some things we do know, including what the atoms inside you and me do on an atom by atom basis. And to me, like the other thing that you're saying, which is that has implications. That's just not a fact alone in the world. It matters for our self-conception of who we are.
Do you remember the first time that you learned that we could attain knowledge about the universe, about reality at that small a scale?
I was very young. You know, I was like 10 years old when I started thinking about these things. Going to my local public library and reading all the books in whichever part of the Dewey Decimal System is physics. So I would read about general relativity and the Big Bang and black holes, but also about particles and fields. And it was just magical to me. Like I knew then that I wanted to do that for a living. I had no idea what that meant, but I figured that's what I want to figure out. Like someone obviously has the job of figuring this stuff out. I would like to be one of them.
I mean, you are, in addition to being an academic, you are a science communicator and you write a great deal and talk to general audiences about these topics. Why do you think that is important?
when you do for a living what I do, thinking about the fundamental nature of reality, right? In some ways, we are parasitical in society. We take in resources from students' tuition, from government grants and whatever, from foundations giving us money, and we do our jobs. And why? Why would anyone give us money to do these jobs, to think about the fundamental nature of reality? I think that the only reason is because they expect that ultimately we will go back and tell people what we've discovered, right? If we're just sharing it with each other, there's no point in supporting this entire enterprise. So to me, the idea that we not only figure things out about the universe, but then share what we figured out with the wider public is 100% part of the job description.
This cycle of inquiry, investigation, discovery, and dissemination, this is the essence of science. Taking these incremental learnings and applying them to the pursuit of greater knowledge is what pushes us forward. That's something Nina does every day. Her work on the Mars rovers is done from a cubicle at the nearby Los Alamos National Laboratory. But in a sense, this is her office. This terrain was formed by volcanic activity some 14 million years ago, and studying its geology might help us better understand the history of the red planet.
We can't go to Mars yet. We're planning on doing that. But if we want to learn about the geology of Mars, we can't do it ourselves. So we use our rovers as our robotic explorers to be able to learn about the chemistry and the mineralogy of rocks on Mars. We're doing that to try to understand whether or not Mars was habitable, so a place that could have supported life, and also whether it was actually inhabited, which is a really amazing question that we were able to maybe answer now.
Of all the rover's many discoveries, the most important might be the existence of organic compounds in Martian soil. Because organic compounds are the carbon-based molecules that form the foundations for life on Earth, their existence on Mars suggests those basic ingredients for life probably existed there too.
We're working on a number of different projects, and one of those is ChemCam, and that's an instrument that's on the Curiosity rover. So if you've seen the rover, right,
Yeah.
It's got this head, this sort of shoebox-sized head with one cyclops eye.
Yeah.
And that shoots a laser. That's our instrument.
Is it analyzing things, or is it actually opening stuff up?
We use it to vaporize just a little bit of rock and then looking at that chemistry.
When did your interest in geology first emerge?
Yeah, I wasn't always interested in geology because
Sure.
that was something my mom was interested in, so obviously it was very lame. But I had an incredible experience when I was 7, when I actually got to go to a local university and look through a telescope for the first time. And we were there to see Halley's Comet. And it was the first time I realized that the sky is not a dome. It's actually space out there.
Yeah.
And there's stuff moving around, and I knew that that's the thing that I wanted to spend the rest of my life thinking about.
Well, there's definitely something very interesting about the fact that you were interested in the stars, comets, rocks that are moving through space, and now you're looking at rocks on the ground, but also, I suppose, rocks on the ground on other planets.
That is something that I never even considered as worthy of study, but it turns out that every rock has a story. And that story could be on this planet, but it could also be on another planet. This is all basalt, and it's really the basic building block of planets. So most planets start out as basically basalt, and then things happen to that basalt and we get different types of rocks. So Mars is inherently basically a basaltic planet with some notable exceptions. So we can actually study basalts here on Earth to have a better understanding of those basalts on Mars. If we find something like a varnish on another planet. We've seen some traces that we think might be like that on Mars. There's some questions that we can answer, but we can't do it with the rover. And this is why we're doing sample return for the very first time.
How are we going to do that? What does the return mission look like?
It's so crazy. It's amazing. I love it. So the first step, of course, is getting the samples. And they're in these little tubes. They're sealed up. So then we're going to send a spacecraft from Earth, and then that orbiter is going to shoot down a lander that will land near the rover. And then the rover will be like, here, have some samples, put some samples in it. And then that has a return launch vehicle that can launch back to space. It will rendezvous with that orbiting spacecraft. It's amazing. And then that whole assembly will go back to Earth, where it will land. Simple, right? Easy, easy, no big deal.
That's wild.
As futuristic as that Mars mission sounds, it's ultimately about studying the past. And there's a lot to be learned from studying the past, and a certain degree of comfort in doing so. No matter which starting point you choose, all roads should inevitably lead back to the present. But trying to anticipate where those roads lead from this moment forward can lead to a great deal of anxiety for some. Which is why I wanted to talk to one of the most optimistic people I know about what the future could look like.
Hey, hi.
It's such a pleasure to meet you in person.
As well. Nice to see you.
Yeah.
Welcome to my place.
Thank you very much. It is a very, very cool spot.
It is a nice, cool spot.
Admiring all of the things.
I can give you a tour. You want a tour first?
A tour would be very cool.
Yeah.
Kevin Kmele is a world-renowned futurist.
This is my little man cave.
As far back as 1985, he was pioneering online communities and social networks. And as the co-founder of Wired magazine, he had his finger on the pulse of technological innovation at a time when the impossible seemed to happen again and again.
This is my curiosity wall.
Okay.
You know, from where's it the window that freeze dry. If you freeze dry them, put them in the freezer. You know, just biological things, really cool. Things here.
That's wild. What determines which things make it onto the wall?
Well, I think they're curious and weird, and so I have a little
Is that
identification.
It's whale. That's like a bailing whale too. Yeah.
All right, you're the second person out of 100 that got that.
Kevin is also a founding board member of the Long Now Foundation, which was established to encourage long-term thinking.
There's this ball, so just pick it up, which is a part of our 10,000-year clock. There's a prototype.
I knew I'd need 2 hands.
Among their many projects are a library and a clock, both designed to last 10,000 years. Keep in mind, the pyramids have only been around for 4,500 years. The Colosseum is barely 2,000 years old. So this is a wildly ambitious project. And the hope is that these monuments can serve as a totem, inspiring humans to think about how we can make generational contributions to the future.
Do you suspect that part of the reason why people are so afraid of the future might be that they just don't have a real perspective on the past?
I think there's nothing that will increase a person's optimism more, in my opinion, than having a really good sense of history, of where we've come from, of how bad things were in the past. Mm-hmm. One of the advantages I had as a young person was I got to be in a time machine. And that time machine was being like in northern Afghanistan in the 70s or parts of the Himalayas, where they were literally living as they were 200 years ago or 500 years ago. It had not changed at all. It was feudal, medieval in every respect. It was very constricted. You didn't have any choice about what you were going to be when you were an adult, what you were going to do. And it was very clear that while this was a really interesting place to visit, I didn't want to live there. So if you read history very impartially, it's very clear that there is such a thing as real progress. Mm-hmm. We have been getting better, and not just materially better, but even ethically, morally better. We've enlarged the circle of empathy around us. And that's one of the things that I think we have to realize as moderns is that we've invented our humanity. It's not something we inherited. We've invented it. We've created it.
When I survey the landscape of public thought, the smartest people in the room, it seems that most of them are worried about something. Yes. Primarily worried whether or not they're talking about solutions. And to the extent they're talking about solutions, there are various prohibitions to stop things from happening. How do you address the specific fears?
It's not that I think our problems are smaller than we think. I think our capacity to solve problems is greater than people think. Mm-hmm. And the problems are far easier to see than the solutions. It requires a lot more imagination. It's more difficult. But the problems propel progress. We have increasing capacity to solve problems. And that's why I'm optimistic.
I think I caught the bug from you with respect to this determined commitment to optimism when it comes to thinking about the future. I've heard you once say that optimism is a moral imperative.
Yeah, exactly.
And I wonder if you could expound on that idea a little bit.
The optimism that I'm talking about is less of an emotional sentiment, kind of a Pollyanna outlook, and more of a kind of a deliberate choice. And that is that we want to try and imagine a future that we want to go to, and a future in the real world. And that future is going to be complicated just by the nature of what we've made already. And that requires us to imagine it first, because we aren't going to arrive at some glorious future that's really complicated by accident, inadvertently. So we have to kind of see it first. And more importantly, once we see it, we have to believe that it can happen. Otherwise, we're not going to get there. So this idea of envisioning a future that we want and then believing that it's possible to get there is an act of optimism.
The future consists of a mind-boggling number of possible outcomes. Through the decisions we make as individuals, as a society, and as a species, we will determine the shape of things to come. To persevere, we'll need to find ingenious solutions to our problems. We'll need to foster curiosity and creativity. So it's strange that we've managed to erect so many artificial barriers between different disciplines.
There's a joke within philosophy circles that, philosophy studies things until it begins to make progress, and then they spin off into a completely different field, and therefore philosophy never looks like it's making progress. But Isaac Newton, Galileo would have called themselves natural philosophers. Is the universe fine-tuned? Why is there something rather than nothing? Can an artificial intelligence be conscious? What is a species biologically? Okay, a whole bunch of questions that are clearly scientific, but also clearly philosophical. Mm-hmm. If you asked a person on the street, what are their most important questions about the nature of reality? Why does reality exist? Did it have a beginning? What banged at the Big Bang, et cetera? Yeah. And you ask these questions of a professional physicist or a philosopher usually, and they will say, no. Those are not the right questions to ask. Uh-huh. We have our questions. What is the relic abundance of this particle from the early universe? Yeah. What is the statistics of galaxy-galaxy correlation functions? And those are all good questions to ask. But they're a little divorced from the everyday person's thing, which is fine. Neither set of questions is bad. Mm-hmm. What's bad is that when the scientists say, no, don't ask that question, ask this question, mm-hmm. right? Because there's a set of questions where you get rewarded within academia as a scientist, not because they're necessarily the most important questions, but because they're the questions on which you can make progress. Making progress is very important. And that's not wrong. That's not like a flaw in the system. We've made tremendous progress over the last 100 years in understanding the fundamental nature of reality by trying to get concrete results that you can test in a laboratory, okay? And asking why is there something rather than nothing does not open up a whole bunch of experiments that you can do that will help illuminate the answer to that question. So I think that it's a matter that scientists need to relax a little, remember what got them interested in it in the first place.
You are oftentimes thinking about things that are way beyond the scope of our normal lives. But I wonder if you give much thought to the grandeur of the cosmos in your work, and if that kind of stirs something in you.
That's why I do this work. Every day I get to see something that no other human has ever seen. And when I think about what that means, and I think about what it means in the larger solar system, in the larger galaxy, in the larger universe, sure, maybe I don't mean anything in the cosmic scale, but that rock and the stuff that makes up me and you, we all started as the same blob of molten rock in our solar system, right? all of our little grains coalesced. We've evolved over time, and now you're here, I'm here, this rock is here, but we really are all from the same place. Mm-hmm. That gives us a sense of our interconnectedness, our connection with each other, mm-hmm. our connection with the larger universe. That's very special. It's amazing that I exist, that you exist. So many cosmic things had to happen for mm-hmm. this moment to be here.
No, it's really beautiful the way you put that. There's a sense in which you're anchoring yourself and saying explicitly, I am part of the broader cosmos. Like the story of this rock is my story as well.
The remarkable fact of our improbable existence is something that I've drawn tremendous inspiration from. And it's likely why I'm so optimistic about the future. It's perhaps a subtle shift in framing, but one that can have a profound impact on how we think about the future.
The things that we have today, the iPhone, cars, were all things that seemed improbable at the time, but somebody had a vision and believed that they could work, and they made it happen. I am fond of imagining if Beethoven or Mozart had been born before we invented the technology of symphonies or violins or pianos. What a loss to the world. You know, if they'd been born 5,000 years earlier, they'd been potato farmers or whatever it was. But here we had the technology, so their genius could be shared with us. And so our world today has been formed by optimists of the past. And so that idea of what evolution gives us is the same thing. It's moving towards more possibilities, more mutualism, more complexity, more ways of being, more ways to be. I think we get meaning by joining or aligning ourselves with those increasing possibilities. And I see my job as trying to expand the possibilities in the world. So I have a future-oriented framework, meaning that I want to be a good ancestor. I want to do things that may pay off the most in future generations. So I think that has to be part of the framework. It's not just thinking of ourselves in the past, but also being a good ancestor for those few generations in the future.
Kevin's message of optimism and stewardship is one that resonates with me. But there is one aspect of the future which I'll admit gives me a touch of anxiety. Something that I contemplate in addition to my own finite nature is the fact that the universe itself might also be finite, and that there is perhaps at some point a kind of great unraveling coming. And that, I suppose I'm probably more concerned about that than I am like my own death, which is a bit odd, maybe, because I won't be there to experience it. But like that bothers me.
So that is something we legitimately don't know, right? I want to emphasize there are things we know, there are things we don't. We don't know what the future holds with much confidence, but we do have ideas. We have a story where 13.8 billion years ago, the universe was in a hot, dense state, as the song leading into the Big Bang Theory comedy TV show would tell you. It's been expanding and cooling ever since, and it will keep expanding and cooling forever. So 13.8 billion years sounds like a long time, but infinity years to the future. So in some sense, the universe is still very young. The stars are going to keep shining for another 10 to the 15 years. So that's 100,000 times the current age of the universe. Plenty of time. But eventually they're going to die. They're going to use up all their fuel. And they're going to fall into black holes, and the black holes are going to gradually evaporate themselves. And so 10 to the 100 years from now, according to this most likely story that we have, the universe is empty and quiet and desolate and cold and remains that way forever. So there is a last thought that any living being will have in our observable universe. We're nowhere close to it now, but that's a finite amount of time between us talking here today and the last thought that will ever be thought.
Yeah, it's hard for that not to bother me a little bit.
Okay, that's okay. Let me say one more thing. We are not equipped to deal with this, right? I mean, this is the mismatch between the manifest image and the scientific image. We grow up, and by grow up, I mean not just like literally grow up, but we are educated, trained through evolutionary history to think about the world in a certain set of ways. And it's kind of bounded and finite, and that's what we have been evolved and trained and raised to do. And now science comes along and gives us these pictures of the universe at ultra small scales, ultra large scales, very early times, very late times. And it's all stuff that is well beyond our capacity to really think about. We can discuss it mathematically, physics-wise, we can write it down, but feeling it in our bones is really hard. And so don't be surprised or feel distressed if this is kind of mind-boggling stuff. If it's not disturbing, you're not doing it right.
Is there room for meaning and purpose in a universe like that,
where the things that give us meaning are all kind of careening towards something else.
You know, a friend of mine, I think, once put it exactly right. He said, people ask, can there be purpose in the universe? And the answer is yes, because I have a purpose and I'm in the universe. And I think that's the right answer. It's not that there can't be purpose or meaningfulness or mattering or caring or love or whatever in the universe. It's that they're not coming from outside. They're not being given to us by something outside of the universe, nor are they sort of built into the fabric of the universe. They are part of what we create, what we bring into existence as these ephemeral, organized, organic, messy, self-conscious, self-aware creatures. And part of literally who we are is that if we don't constantly take in things from the outside world, whether it's food or water or air, but also interaction and things like that, we go out of alignment, we become unstable. So that fact that we need something, that we have wants, that we have desires, that we have feelings, we can talk about where that comes from, but it's absolutely part of who we are as human beings. And part of that is projecting our imaginations into the future and saying, I would like to end up here and not there. That's a purpose. The universe doesn't have that, but I have that, and that's perfectly legit.
I suppose part of my reason for thinking about and being a little nervous about the far future is because I think about preserving consciousness in the universe and making certain that there's something in the cosmos that's going on with this project that we have of kind of contemplating ourselves and the cosmos more broadly and our place in it and what it all is and why it matters. It feels important. And I would hope that we make it off-world before our sun expands and makes it too uncomfortable to live here, and that there's somewhere in the universe where our species continues, or at least our descendants. I wonder if you think beyond none of the tangible big problems that we have to solve today, stuff like climate change. It's a big deal. And we want to address that. Similarly big deal in my estimation is at some point, like that thing, it's going to become impractical for us to live here. We'll need to find someplace else to go. Can we make meaningful contributions towards solving that kind of problem today?
I am convinced that the better we understand the universe, the more capacity we will have for shaping the universe in good ways. Probably you could also make a statement similar in content to shaping the universe in bad ways.
Sure.
But at least we'll have, more capacities. And you could make an argument, why does the current generation of human beings matter more than the future generation? They're all human beings. They all exist. And guess what? There's going to be a lot more of them. Therefore, we don't matter at all. Our only purpose is to make sure that they're there. I don't think that's right, that argument, but I don't know what the right argument is. I'm absolutely sympathetic to the idea that you proposed that, the fact that there exist in our universe creatures that are capable of self-awareness and love and consciousness, that sounds like a good thing. I would like that to continue on. But if there's some choice that I can make now that might affect whether or not there are 200 trillion such beings in the future versus 150 trillion? Does that matter? All I'm saying is we're just not that good at this. Our simple-minded attempts to add up all the different good in the world and try to maximize that, I don't think that's the right thing to do, but I don't know what the right thing to do is. So what I'm actually in favor of is just being a little bit more modest in our claims and say, let's try to clean up our stoop in front of our own house right now. Try to preserve life on this planet, try to make people happy, there's no reason with all the wealth we have in the world to have so many people suffering in the world, right? And I think that's something that is more immediate and important to me than worrying about 100 generations in the future. I don't want to let the human race go extinct, but I don't think that my immediate actions here are going to, given that there are people in the future, are going to affect their lives in predictable ways very much. So I'm going to have more modest goals.
The Earth has been essentially, many different planets over its history. And many of those planets are not hospitable to us in particular.
Yeah.
So, the idea of trying to go back to a mythical perfection of nature, there is no such thing as that. But we do know that if things change in certain directions, then we cease to be able to exist. And so just selfishly, I want to be able to maintain an environment which is, habitable for humans, right? So sure, the sun will become a red giant and completely engulf this planet. So hopefully by then we'll find somewhere else to go, right? We've got a few billion years, right? That's a pretty uncomfortable thought, but I do hope that we can, instead of taking fear from that, just understand the context in which we live our lives, I think it's really hard for us as a species to think long term, but it's absolutely critical, because if we don't, I feel like our consciousness is almost wasted on us, right? We have this incredible capacity to think about the past, the present, and the future. And most creatures don't really have a good sense of the future, but we do. What are we going to do with this gift? How are we going to use it? We can use it to our benefit, and we can use it for the benefit of all creatures on this planet. And so I really hope that we do that.
The best of our science seems to tell us that the universe will indeed end. But the amount of time between now and then is almost incomprehensible. The amazing and even poetic thing is that the laws and processes that will one day bring about the end of all things are the same ones that led to the emergence of new complexity in the universe, new stars, new planets, and even new forms of life.
The story that I tell myself about our cosmic journey is that the general understanding that we have right now, that we're on this kind of long level slide to heat death, to uniformity. That's what it is. But that there are these little threads, these little clusters of negative entropy, what I call exotropy, which is the opposite of entropy, where things become more ordered over time. And that they are self-organizing. And that's what life does. It takes the entropy and actually accelerates it to make order, to make the self-organizing life that we know. So you have the probable going on, and if you accelerate making the probable, you can get the improbable. So life and our own existence are very, very improbable. It's going the opposite way from the rest of the universe.
This improbable endowment of existence is an extraordinary gift. It's also fleeting. But if you use it wisely, it can be rich with meaning and purpose.
The typical average human lifespan is about 3 billion heartbeats. And I love that number, 3 billion, because it's pretty big, 3 billion, but it's not wildly big. Like, it's tiny compared to the federal budget, right? We interact with much bigger numbers all the time. And a heartbeat is a very tangible amount of time. It's not like, I could just say 80 years. It's the same number. But a heartbeat is just, they're constantly going by, and I only have 3 billion of them. And then it's going to be the end. And to me, that focuses the mind, right? That really drives home the fact that we have a finite span here on Earth. There's no set of instructions given to us by the outside universe about how to use those 3 billion heartbeats. It's up to us. And this is both terrifying and also exhilarating, right?
It's liberating.
It's liberating while also very anxiety-inducing, right? Like, you're saying it's up to me? Yes, that is what I'm saying.
Yeah.
Maybe it's only natural that we look for meaning and purpose beyond ourselves, to reach for and hope for eternity, definite answers. There's certainly no shortage of people who claim to have all the answers, enthusiastically offering prescriptions for your happiness. But what I've concluded is that we are the authors of our own meaning. We define our own purpose against the backdrop of an expansive universe that has seen life begin and will perhaps see all of it end. You are here, and your perspective is unique. The story of the cosmos is incomplete without that perspective. How you choose to live your life is defined by what you value most. So you owe it to yourself to figure out precisely what that is.
So come with me.
Okay.
Embark on a journey. Read a book. Read 1,000,000 books. Talk to people from all walks of life. Ask big, audacious questions. Don't settle for lazy answers. And above all, make the most of the time you have while you're here.